In the next part of our experiment, we wanted to find out if the results from our experiment would be statistically significant. We did this by making a simulation of our results. In column A, you can see the number of digits that the treatment group with the pencil and paper got right. We had 40 students in this group. In column B, you can see the treatment who had the fee trainer on the computer. We had 35 students in this group. On the next slide, we decided to graph our results in box plots. The graph on the top was the paper and pencil graph, and the bottom was the computer group. When you see the top graph, you can see that the middle 50% had less variation due to the smaller IQR. The top graph also had a median that was higher by 2. These results are very similar, and therefore we believe that they are not statistically significant. In the next slide, we found the mean of the paper and pencil group's results and the mean of the computer group's results. We found the difference of these two means to be 2.6. We wanted to know how likely it was that this difference was statistically significant in our experiment, to see if this result of 2.6 could have been gotten randomly through and not through the difference in our treatments. So to answer this question, we set up a simulation. First, we chose to pool everyone together, as you can see in the all column. After this, we randomized by using the Control and R key on our computer. Every time we hit these keys, it pools, randomizes, and redistributes the subjects. As we randomize, our program captures all the mean differences in column G. In the next slide, you can see that our difference of 2.6 was among many others in this range. We wanted to calculate and estimate what kind of difference there would need to be to have a statistically significant experiment, in that the differences were due to the treatment and not allocation. So we decided that a mean difference would have to be above 4 to show that it was more extreme than the middle plots, dots in the dot plot, and show that that difference was from the treatment and not random variation. And that it would be statistically significant because less than 8% of the total values in our simulation would have been this extreme.